Okay, now we go to next video. Okay, this video is okay, just now I show you one step, right? Okay, this is another step. Okay, class, please watch this video and then you let me know which step is skipped. Okay, it's easier, but there's one step is skipped. Hopefully you can find out what is the step is skipped. Okay, watch this video and then get the which step is skipped.
Alright, so in this video we're going to solve a system of linear equations, 3 equations, and we're going to do this by using inverses. So the first thing I've done here, I've actually completed a couple steps to make this go a little bit quicker. I've written this as a matrix equation, so I took the coefficients, so we've got 1, 2, 2, 3, negative 2, 1, 2, 1, negative 1, and then we've got our column of our variables, x, y, z. And then we've got our values on the right of 5, negative 6, and negative 1. The first thing we would have to do is compute the determinant of this matrix A. We're going to have to find the inverse of matrix A, and I'm going to use this using determinants and cofactors. And let's see, so I've actually expanded this along the first row. So if we expand along the first row, we would have to use the determinants given by negative 2, 1, 1, and negative 1. Then we would use minus the second value in our first row, and then we would use the determinant given by 3, 1, 2, and negative 1. Then we would have plus 2 times the determinant given by 3, negative 2, 2, and 1. I went ahead and computed this. It looks like our first one we get 2 minus 1, which is 1. We'll get negative 3 minus 2, which is negative 5. We'll get 3 plus 4, which will be 7. And after I did the arithmetic here, it looks like our determinant is the value 25. Alright, the next thing we would have to do is produce this cofactor matrix using our matrix A. And again, I've actually written all that out as well. So remember we have to change signs, positive, negative, positive, negative, positive, negative, positive, negative, positive. So again, if you cover up the first row and the first column, so if we cover up the first row and the first column, we'll use the values negative 2, 1, 1, and negative 1. If we cover up the first row, second column, we'll use the values 3, 1, 2, negative 1. If we cover up the first row, third column, we'll use 3, negative 2, 2, and 1. And likewise, let's see, if we cover up the second row and first column, we'll use 2, 2, 1, and negative 1. If we cover up the second row, second column, we'll use 1, 2, 2, and negative 1. And if we cover up the second row and third column, we'll have 1, 2, 2, and 1. Lastly, if we cover up the third row and the first column, we've got 2, 2, negative 2, and 1 left. If we cover up the third row, second column, we'll be left with 1, 2, 3, and 1. And lastly, if we cover up the third row and third column, we'll be left with 1, 2, 3, and negative 2. So I'm going to go ahead and compute this out now, all of these values. I didn't do that yet. So let's see if we can't compute all of these values. Let's see, it looks like we would get 2 minus 1, which would be, so 2 minus 1 would just be 1. It looks like we would get negative 3 minus 2, which would be negative 5, but the extra negative would make it positive 5. We would have 3 minus negative 4, or 3 plus 4, which would be 7. It looks like we would have negative 2 minus 2, which would be negative 4, but the extra negative would make a positive 4. It looks like we would have negative 1 minus 4, which would be negative 5. We would have 1 minus 4, which would be negative 3, but the extra negative would make it a positive 3. Then we would have 2 minus negative 4, so we would have 2 plus 4, which would give us 6. We would have 1 minus 6. 1 minus 6 would be negative 5, but the extra negative would make it positive 5. Then we would have negative 2 minus 6, which would be negative 8. So to get the actual inverse matrix, we have to do 2 things. We have to reflect this matrix about the diagonal. So the 1, the -5, and the -8, we'll leave that alone. So the 4 and the 5 will switch places.
Okay, what step is skipped here? It did minor, but in the minor it did something else. Cofactor. So it means that you can see when he put the minor, when he put modulus, he already stated there. What you can see or not? The previous one. The previous. Okay, you can see or not? Here, positive, negative, positive. Can you see or not? Because when I teach you, I put just minor only. Okay, from minor I change to cofactor. So then only I circle the 4, this one. Okay, in this method, he already stated that negative, negative, negative. The 4 circles, he already put here. So he did double method in this way. Okay, but this is fastest way. If you can understand, you can copy it, or you can use the previous way. Okay, and then if you see here, okay, next, you continue.
We have to do 2 things. We have to reflect this matrix about the diagonal.
This is from cofactor, right? Okay, what is doing? Actually, he's doing transpose, but you listen first,
We'll leave that alone. So the 4 and the 5 will switch places. The 6 and the 7 will switch places. And then our 3 and our 5 will switch places. Okay, we also have to multiply that by...
Faham tak yang ni? Okay, we normally from the cofactor we go for adjoint, we just transpose. Okay, in this case it just symmetry, and then when symmetry it just terbalikkan the alphabets. So you just symmetry in with the red marker. Okay, where it change, it switch the place for 4 and 5. You can see now 4 and 5, and then 6 and 7, and then 5 and 3. So this is another way. I mean, you already learned transpose, I teach transpose way. But in this method, you just do symmetry way. Okay or not? And then you continue.
1 over the determinant. But we said the determinant was the value 25. So we'll get 1 over 25. This is now going to be our inverse matrix. Okay, we could always, run this, we could multiply all the entries by 1 over 25. So we get 1 over 25, 4 over 25, 6 over 25. We would get 5 over 25, which would be 1/5. Looks like we would get -1/5 for our next entry, +1/5 for our third entry there in the second row. Then we would have 7 over 25, 3 over 25, and also -8 over 25. So let's see, now that we've got our matrix A inverse, we can go back to the very original problem. And the idea is, if we multiply A inverse by this matrix with 5, -6, and 1, if we do that arithmetic, we'll actually get our solution here. So let's see, so I'm going to copy down our matrix A. We have 1 over 25, 4 over 25, 6 over 25, 1/5, -1/5, +1/5. We've got 7 over 25, 3 over 25, and -8 over 25. So now I'm going to multiply this by 5, -6, and -1. Okay, so those were our values before. And now, once we do this arithmetic, we will have our answer. So let's see here. I'm going to give myself a little bit of space. So we'll have 5 times 1 over 25, which will be 1/5, plus, let's see, it looks like we'll have -24 over 25. And then it looks like if we multiply 6 over 25 and -1, we'll have a -6 over 25. Let's see, our next value, it looks like we're going to have, sorry, I was thinking there for a second. So we're going to have 1/5 times 5, which is positive 1. Negative 1/5 times negative 6 is going to give us a positive 6/5. And then 1/5 times negative 1 will give us a negative 1/5. Let's see, it looks like in our last row, we'll have 7 times 5, which is 35 over 25. Plus, we'll have, it looks like negative 18 over 25. And at the very end, it looks like we'll have positive 8 over 25. And let's see, if we simplify all this stuff down, we could make our first row, just to get common denominators, we could make that 5 over 25. So let's see, if we do 5 over 25, let's see, 5 over 25, well, let's see, negative 24 plus negative 6 would be negative 30. Negative 30 plus 5 would be negative 25 over 25, which would give us negative 1. It looks like in our second row, let's see, 6/5 minus 1/5 would be 5/5, or 1. 1 plus 1 would give us 2. And let's see, in our last row here, we've got, it looks like negative 18 plus 8, which would be negative 10. Negative 10 plus 35 would be 25. 25 over 25 is positive 1. And we've now got our solution for our original system of linear equations. It says x should be negative 1, y would have the value 2, and z would have the value positive 1. Alright, so in this video we're going to solve a system.
Okay, so enjoy watching video. Okay, so so this is another way to find the minor. Okay, and then you skip the step of transpose. We can find another way is symmetry. Okay, so same method. So now we're going to do exercise in our book. So go to your book, page 204. Okay, exercise 9. Okay, if you see exercise 9, you got only 2 questions in your book. Inverse, using the inverse matrix method. Am I right? Yeah. Not enough questions, right? No. Okay. So there is additional 1 question for you. Okay. Additional 1 more question, because you see, they already gave you 2 pages in your book. So you must fill up this page, right? So the extra question is this one. Okay, copy this question, class. Copy this question in any page, either page 205 or 207, the empty space. Page 205 or 207, 2a minus 3b plus c is equals to 5. A plus b plus c equivalent to 7. And then the last equation is 3a minus 4c equivalent to 10. Can see or not? Can Okay, so now I'm going to show you the first step for this question. Okay, these linear equations you're going to put in the matrix form. Okay, how? Okay, the first step. Okay, first linear equation. So you'll be getting 2 minus 3, 1. So you close. You'll be here A, B, C. Equivalent to 5. Okay, next. The next linear equation is 1, 1, 1. So equivalent to 7. Okay, last. 3. Okay, what is missing there is B. So it's equivalent to 0. Negative 4 is equivalent to 10. So please careful because there's 3a minus 4c. You can get like this question. Or you can get questions without rearrangement. So make sure you rearrange properly and then you continue the questions. Okay? Okay class, you can start the exercise 9 now.